Welcome back to this lesson on the topic of Python programming. In the last lesson, we had a look at implementing a program that could take in a number and calculate the square of said number. In this lesson, we're going to have a look at how we can write a program that will take in a number and calculate the square root of said number. Success for this lesson will look like the successful implementation of a program that would calculate square roots of a number. And furthermore, success for this lesson will look like you being able to explain the numerical process of determining the square root of a number. Now, as a bit of a refresher, in the previous lesson we had a look at this number sequence here, so 1, 4, 9, 16 and 25, and we concluded that the numbers up the top here, they were square numbers, and the numbers down the bottom, they were the square roots of the square numbers here. So in this lesson, we're going to go in the opposite direction to what we did last lesson. So last lesson, we looked at going 4 and 4 equals 16, 5 and 5 is 25. We're going to go from 9, or the square root of 9 is 3, the square root of 16 is 4, and the square root of 25 is 5. But we want to be able to do this for all numbers, including these numbers here, which aren't square numbers. So we're going to be able to calculate the square roots of these numbers, which aren't really apparent at this point in time. Now, before we can do any programming, we have to jump into a little bit of theory. We have to figure out, is there an algorithm for calculating the square roots of numbers? And thankfully for us, there is, and it's actually not that difficult. In fact, it's a really old method that the Babylonians used to calculate the square root of 2 thousands of years ago. So suppose we have a number and we'll call it we'll give it the variable s, and we'll label that as the square number. Now, if we wanted to calculate the square root of a number, we could say r is equal to square root of s, and life is good. However, in programming, we can't take this liberty. It's not possible. So rather, we'll take a step back and we'll go, let's take a stab in the dark, and we'll say, well, if we've got a square number, the square root of that number is equal to this guess of square root. Now, if we try and calculate the square root of this number, so r, we can go s divided by our guess, and this will give us an approximation of our square root. So this is all well and good. R is equal to s divided by g. Now the question is, what sort of number should we choose for g? And let's go easy. We'll just pick the number 1. So we'll calculate the root of, let's go 16. So we'll go square of 16. And let's take a guess, and let's say that the square root of 16 is half of 16. So s divided by 2, which is 8. And now we want to calculate the root. So bring in a calculator and we'll say the square root, so 16 divided by 8, and that's going to be 2. Alright, that's well and good, but it's not really close because we know the square root of 16 is going to be 4. So we need to tweak our algorithm a bit. So let's scrub that out. We'll go across the same idea, but we'll change it in that the square divided by the guess plus the guess times a half, like so. So let's go 16 divided by, in our case, 8 plus 8 times 0.5. And now we've got an overshoot where we're at 5. So we're no longer at 2, rather we're at 5. Alright, suppose we did this again. So our guess is a little bit closer. The first time our guess was 8, now our guess is 5. Let's run through this again. Let's go, we'll go 16 divided by 5 plus 5 times a half. Now we're going to get to 4.1, so we're getting a little bit better. So our result is 4.1. Let's go one more time. We'll go 16 divided by 4.1 plus 4.1 times 0.5. And we get even closer. We're at 4.00121. So what you're going to find is that every time you go through or you put your guess, so you're squaring your guess through this algorithm here, you're going to get closer and closer to the actual square root of a number. Now if I go ahead and just program this into the calculator, so let's go, we'll start off with our first guess of 8 plus 8 times 0.5. And now I'm going to actually program it in the calculator. So I'll go 16 divided by the answer plus the answer times 0.5. Watch what happens every time I hit the equal sign. We get 5 to 4.1 to 4.0121, closer, and we've finally hit it. So if we keep putting our guess through this algorithm, we get closer and closer until we finally get to our result. So what we'll do is we'll use this algorithm here to implement the program that will calculate the square root. So breaking this down into step-by-step instructions, we need to get a number, take a guess, so guess the square root, run through the algorithm, and repeat until we're happy. Alright, cool. So let's jump over and let's look at a template here. So this is a template for our program. The first instruction is we're looking at the output, tell me a number to root. We have to get a number from the user. Then we have to guess the square root. And then calculate the square root. And finally, tell the user the result. Okay, so let's set it up. We're going to go def, we'll call it root, then we'll go square, then let's just write pass for now, and I need to put in my colon, of course. Okay, now we'll do the main, set up our main template, put in a pass, and then finally this is telling the interpreter to run the program from main here. Alright, our first job is to get a number from the user. So let's go square input input, tell me a number to root. And of course, this is going to give us a word, so we have to convert it to a number using int. Okay, and now what we're going to do is we're going to take a guess. And let's just say let's guess 1 for now and leave it at that. And we'll run it and see what it does. Tell me a number to root. We'll go 5. And it seems to be working. Okay, so we've got get a number from user, guess the square root. We've done that. Now calculate the square root. So what that infers is we need to use this function here. And we'll go root equals root, like so, in capitals, and then we'll put in our square. Now this isn't actually going to do anything because it's a pass up here, but we'll leave that for now and go to our final one, tell the user the result. So the square root of, let's just copy that, and we'll go print, like so, string square plus is, and then finally string, and we'll go root, like so. So when we run this, we should see some output similar to this, but the numbers aren't going to be quite right yet because we still need to implement the functionality. So going ahead and running this, tell me a number to root, 16, and it says the square root of 16 is none. Okay, so next step is we actually have to implement this algorithm here. So if we swap back to this slide, we are going to implement this here. So root equals the square divided by the guess plus the guess times 0.5. So what that's going to look like is we can't just have square there, we need to put in a guess. So guess and square. Then we're going to go, we'll put it as root is equal to, in brackets, square divided by guess plus guess times 0.5. So all I've gone and done is I've copied this algorithm here, or this formula here, and I've simply thrown it up here. So square divided by guess here plus guess, which is here. And then you've got the 0.5 at the end. And we have to edit this down here. So we're expecting 2. We have to put in the guess as well. Like so. And if we run it, we get still none. Ooh, forgot to return. So we need to return root back to the calling method. So now when we run it, we should get 8.5. So still a long way off. Let's change it to half. So guess is half, like so. And we put in 16 and we get better, 5. Now remember, this algorithm only worked because we kept calling it over and over again. So the more times we put our guess through this equation here, the closer we're going to get to the actual square root. So in saying that, let's go through this a few times. So we'll break this out like so, and we'll copy it down. Say, actually no, we won't do that. We'll keep running this like this, and we'll copy it down. So we'll go 4 times. And rather than passing the square or the guess back into it, we'll pass the root back into it. So the root here. So we'll go guess equals root. And we'll have to copy that. So running 16, we go, our first guess is 5. Next one is 4.1. Then we go 4.0121 and 4. Long number. So it's close to what we saw in our calculator here. But we're not quite. We want 4.0. So let's keep going. Like so. Tell me a number, 16. And there we go. We finally get to it after 1, 2, 3, 4, 5, 6, 7. 7 runs through the algorithm. Now this is alright, it works, but I think we can do better than that. We don't want to have all of this bloat here. Rather, we want to be able to tell Python to just run through it enough times to be sure that we're getting the right result. So what we can do is we can modify this. We'll get rid of all of these. We'll go like that. Then we'll say root equals guess, like so. Now we're going to use something called a for loop. So we'll type for I in range. We'll type in 10. Then we have to push all of these in by 1, like so. So what this is going to do, this little bit of code here, is going to tell Python to execute this code here 10 times over. But one small thing, it's not root equals guess, it's guess equals root. So if we run this, 16, what you can see is it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it runs through 10 different times. Now we can run this with a different number as well. So let's go 25. See how good it is. And of course, it comes up with the value as again. Now there's probably better ways in which we could check whether we've actually hit the result or not, but it's a little bit too complicated to do it in this lesson here. For now, success will look like getting a program to actually calculate the square root using the brute force method of just guessing how many times it should take. Now this is all well and good, but we don't like having all of these messages on the screen. So what we can do to clean it all up is we'll move the print statement outside of this loop, and we'll only output the message when the loop is finished, like so. So when we run this, we'll only see 1 where it actually shows us the actual result. So we'll go, tell me the number to root, 16, and voila. The square root of 16 is 4.0. So when we flick back to the output of the intended program, it says tell me a number to root, it says 16, and the square root of 16 is 4. So we've basically implemented the functionality that we were after. Alright, so in summary, what we set out to do in this lesson was to create a program that could calculate the square roots of numbers. So we were able to do that with our program here. And secondly, the most important part of this lesson is you being able to explain the process involved in calculating the square root of a number numerically. So if you manage to get all the way through this, then well done. Now the challenge I set to you is I want you to figure out, is there a way to calculate the cube root of a number or the fourth root of a number? You can do the square root of a number, so see what you can do to the algorithm so it can calculate the cube root, the fourth root, the fifth root, and so on.